Just dropped another message in the chat. Yeah, looks like you're trying to reconnect with your audio. Hey, Zach, I can hear you now. Um,
Oh, okay. Something happened.
yes, are you able to just tell me if you see the line in red on the screen?
Yeah, I do see the line.
Okay, great. This is the
Yeah, I
secant
couldn't
line.
hear you for any of that.
Okay, so the just the recap is we're putting a point here, -2, 4, because that's x equals -2. X equals 0 is
Uh-huh.
up here, and you just connect the dots.
Okay. So,
Now we do have to do this average rate of change, but that's just drawing in the secant line. Do you have a question?
sorry, I'm just silencing my phone right now. I'm getting some messages. All right. Sorry about that. Okay, so we know with the given equation that we have to find the rate of change from like the x's.
Well, they've already given you the
So,
graph, so you don't have to do any of that. If you didn't have the
uh-huh,
graph,
then we'd have to do that. So
yeah.
like we see that we have minus
Except,
2 and 0.
sorry, I don't mean to interrupt you. This is not
Oh, good.
the graph is this is minus x squared plus 8.
Minus x squared plus 8.
I don't know where the disconnect is with your teacher. Actually, this isn't even the right graph. No, I guess it is. Yeah, it is. So this minus x squared plus 8 is the graph. Your teacher left that out in this. Anyway, the
Okay.
point, so to get this ordered pair here, you're putting -2 in for x to get the y value, 0 in for x to get the y value.
And then, so what's this like line called that's going
The,
from
se-
point to point?
the secant line.
A secant line. So
Yes.
how do you, what, so does it just go on forever?
Yes.
And then we're putting it in to figure out what the slope is?
We're going to find the slope, but um, the secant line is just a line between 2 points on the graph.
So what if it said something like 0 to 2? Then would I have the line go like from those 2 points?
Yeah, I think that's what it asked for in the second question.
Oh, okay. Oh, yeah, it does. All right.
B. Yeah, that's a good question.
And then should I mark them like differently for the second line, you think, or
Yeah, I mean, I would if you had different colored pencils or pens or highlighter or something, I would do it differently.
okay. All right. So I guess we have we have the line for the secant line, which helps us find like the rise of a run. So what does the AROC mean in this scenario?
Slope, slope. So
The
you can
slope.
actually do, yeah, you can actually do rise over run if you want, because you have the graph and because you have the points. There's a couple of other ways to do it.
Okay. So what do you think is the best way to tackle it?
Uh, the formula. So AROC is f of b minus f of a over b minus a. And the first x value is a, the second x value is b. So it's really f of 0 minus f of -2 over 0 minus a -2.
So then I just plug those in like many times pretty much.
Yeah, so so the f of x is minus x squared plus 8. So f of 0 means minus 0 squared plus 8.
So then f equals minus x squared plus 8 f of 0 equals minus 0 squared plus 8. So that so that's another way to do it.
We're gonna get the same result.
Oh,
The
and
f
that
of
would be
0 is 8. And then we got to find f of -2, which is putting -2 in for x.
um so why is it getting 8? Is it just because like
0
minus
squared,
0 times minus 0 is just straight up 0, so then it's just 8?
no, order of operations, you square 0 first. 0 squared is 0, -0 is 0, 0 plus 8 is 0. Because here in this one, you have to apply the right order of operations. -2 squared is 4. You negate the 4, that's -4 plus 8 is 4.
So are you doing a different line for each like x coordinate? Like
When
one of
you say,
them's with 0, one of them. Like, are
yeah,
you doing a
yeah,
different equation for each?
same equation for each x value.
Okay. So I kind of like the top one more than the bottom one, honestly. Like, can I pick that one over the other?
You mean just looking at the graph?
Or I mean, like the like f0 minus f minus 2 over
Well, no,
0
these are
minus.
related. Like this is getting the value that goes in there.
Oh, oh, oh. So
And
then,
f of -2 is getting the value that goes in there.
okay. So then I'm going to write that out real quick. Minus 2 squared plus 8 equals 4. So once I have that minus 4 plus 8 equals positive 4. So then I'll have this 8 and 4. But now what do I do with that? Like, do I insert it into the part above, the AROC above?
Just make sure you're seeing my screen. Yeah, you are. Yeah, no, you're putting them into the formula. The formula is find f of 0, find f of -2, 8 minus 4, and then this on the bottom becomes 0 plus 2. You're
And then
you're
that's positive 2.
yeah, or 2 over 1, or just 2.
So,
But what this is the slope between these 2 points. It's the rise over the run. Like how much up am I going? How much to the right am I going?
you're going up by 4 and to the right by 2.
Okay, so your rise over your run is 4 over 2, which is 2 over 1, which is exactly the same as what we have down here.
Uh-huh. So should I just do the rise over run rather than all those formulas?
If you have the graph, yes, you should, but you won't have the
Okay.
graph in all of them.
So rise over run. So the rise over run. So the rise would always be above it.
Yep.
And there's no such thing as a run over rise, right? Like I don't think I've ever
Only,
heard.
yeah, it's only the rise over the run.
Okay. So then I guess
We got a part B that will help, I guess, because you'll do another example of this. Or do you have more questions on A?
so basically like in summary, so I'm given that equation, I mean that graph, and then I'm supposed to figure out the rate of change, which is basically just the rise over run. So I take it and then I make the line connecting the points given, which is minus 2 and 0, and then I have to just basically see how much it goes up and how much it goes to the right. and then I get my answer. And I can't hear you again, just by the way.
Okay, yeah, I am here.
Oh,
Um,
my bad.
I think doing another problem will help. So, it's the same question. Basically, we're going to do the same thing. We're just going to draw the secant line and we're also going to calculate the average rate of change.
Okay. So I think, so we already drew out that secant line from 0 to
Yeah.
2.
Yeah.
And
So it's this
then,
one here and a fresh graph, but you can figure out the slope pretty quickly here. You go, like this.
wait, so
That's
it
the
goes,
rise.
so you'd put it down there rather than to
You
going out to
have
the right?
you have to do the rise first. You go up or down, then to the right.
Right, because it always has to go to the right.
Yeah.
Forgot about that. So then run, rise. And I believe it's just going to be the exact same numbers.
When you go
Just,
down, it's negative though.
yeah. So then that would be -4 over +2.
Right. So -2/1.
2 over 1, -2 is a whole. So then, without calculating the slope, how does the average rate of change of this interval compare to the secant line of from part A? Um,
So basically, they're asking how does this number -2 compare to this number +2?
oh, it's basically the same. It's the so it's like it's moving the same distance, just except it has to go down rather than up, therefore making it negative.
Yeah, and you could just say it's opposite in sign. That's a weird question. We should calculate the average rate of change though. And if you don't want to do it for this one, we can do it for different numbers, but we should do another AROC calculation.
Oh,
Actually, that part C isn't quite that. But yeah, we should do another average rate of change. So let's do it for x equals 0 to x equals 2. This is your A and this is your B. So again, it's f of B minus f of A over B minus A. So it's f of 2 minus f of 0 over 2 minus 0.
so and then our coordinates are 0 and 2, correct?
Yeah, so let's just say you didn't have the graph. You would have to go and figure out f of 2. That's the more normal way that you'd be asked to do average rate of change is you're given a function and you have to do it by hand. So could you
Oh,
calculate this for us, please?
yes. F squared equals -2 squared plus 8, and then that would be +4 for. Oh wait, no. So that's for the 2. Now I have to do the 0, correct?
Now you have to do 0, yeah.
And then that would just straight up be 8.
Yeah. So
And
these are the
then
numbers that go into the formula here. It's 8 minus 4 over 2 minus 0.
and
Like
then
this takes the
so
place of
those
this.
so the 8 and the 4,
Oops, I
8.
put I put those in the wrong spot.
So oh, sorry, what?
Well, I was just trying to show you where they go.
Oh, okay, my bad. So so the 8 and the 4 are from the equations, and
Yeah,
then the 2 and the 0 are from the x
they're just
coordinates.
yeah, they're just the numbers.
Okay, so then that would be 4 over 2, which equals +2. So then
Uh, yeah, that doesn't look right.
that doesn't, because I feel like it would have to be. Negative, correct?
Yeah, so what did I mess up here? I did put them in the wrong order. It is 4 minus 8.
Oh,
Sorry
okay.
about that.
All good. I guess it still gives you the same thing pretty much. So then we get that minus 2, and that's basically the equation.
Yes.
And then what is the end behavior?
No, we
Of,
got to write. We got to do C. We have not done C.
oh, was
So,
that not all 4C?
well, C is the slope of the line.
Uh-huh.
So what do you need for a line?
Um,
Or what's an equation of a line that you know?
y2 minus y1 over x2 minus x1.
That's for slope, equation of a
Um,
line.
fx, no, y, mx plus b? No,
Y equals mx plus b is 1.
but that's probably
That's
not the
one.
right one.
It's okay. There's not a right or a wrong
Oh,
here.
x, yeah, mxx minus x1.
All right, so the choice here comes down to what you're given. What do you have? What do you have? And if you go back to the graph or we go up to where the blue line is, you have the slope of this line, right? That's the average rate of change. You have the slope. It's
Yeah.
-2. Okay. Do you know the y-intercept?
Yeah, it is 0, 8.
Right. So it's probably better to use this one because the slope is -2 and the b value is 8.
V value is 8. So then y equals minus 2x plus 8. And then is that just,
That's it.
oh, right, yeah, write the equation.
Yeah.
Um, so what is the end behavior of the above function? And then with that, so I, so
All
that
right.
basically, so C, okay, so B is asking pretty much to explain why it's similar to A, and you just say it's the opposite side pretty much.
Yeah.
Then C, you have to figure out like just the equation for that decreasing interval.
Okay, so the end behavior refers to the original function, the graph that's given. So there's two directions you have to go. You have to say as x goes to infinity, and what that means, it means to the right forever.
Oh, oh yeah,
So
actually, yeah, I don't really understand this one super well. The like
so, so
infinity stuff.
imagine you're standing up here at the top and you go to the right on the curve.
Uh-huh.
How far down, 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 down do you go?
You just go down forever.
What do we call forever in math world?
Infinity.
Infinity is up here at the top. What's the other
Um,
one? Negative
I cannot
infinity.
remember.
Negative
Oh,
infinity.
right. Okay. Yeah, that's overthought that one.
So this first part, what you have to remember about this first part is that what this language actually means. It means to the right forever. As x goes to negative infinity, so what this means is to the left forever.
To the left forever. So negative infinity is could be for both in this scenario.
Yeah, Yep.
So then, what if the graph is going up and also down? What would you call that?
It can't. It has to go to one way or another.
Like it can't have like I don't know, like almost like a unwrapped like paper clip kind of thing where it's like
Well,
X
it
zero
could look
zero.
like this. Is that what you're referring
Yeah,
to? Yeah,
yeah,
that's
that's what
okay.
I'm.
We'll look at this one next. Um,
Oh,
but this one, if you go to the left, if you tumble down to the left, down, 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 you're going down to negative infinity. Is that okay?
yes, that makes sense. So
All right,
like
so
for
let's
the
look.
formula for that real quick. Um, so it's saying as x goes to infinity, f of x is just negative infinity. So like I just don't understand like the order in that
Yeah,
equation.
well, full disclosure, your textbooks flip this order, and your teacher might as well, which is
Uh-huh.
even more confusing. But you say as you go to the right forever, and this is the notation that follows to say that.
Hmm.
Like you have
Oh,
to
okay. So as you go to x forever, you happen to be going to negative infinity.
f of x means the y goes down forever. These
Okay.
are, and this is just notation. This is how you explain it in words. Like in words, it's as x goes to the right forever, y goes down forever. But we use these symbols to mean that,
Uh-huh.
that's just the math world.
Yeah. Okay, that makes more sense now.
It's like why does this symbol mean the ratio of circumference to diameter? Because somebody came up with it and said it does.
Uh-huh.
These are the rules. These are just the rules of the game.
Okay. Sounds good.
Okay, so let's look at this another example here because this is kind of what you were wondering about, and it's a good question. As x goes to infinity, so as you go to the right forever, what happens to the y value here?
Increases.
F of x goes to infinity, positive infinity. But as you go to the left forever, as you go to negative infinity, as you go traverse this curve to the left, what
It
happens?
will
Well,
be
you go to
negative.
yeah, there you go.
So then, okay, so it can have different like
Yeah.
infinities in the same thing.
Yep.
And am I always gonna look at it from, so will my starting point always be like 0, 0, or like how will I figure out my starting point? Or
Well,
is it just
you don't really care what's going on in the middle. You care about like as you go to out forever.
oh
So
so
like
like
you can
for
start
like
at zero. You can start at zero, but you got to go out far enough to where you know what's happening.
so basically so it's kind of obvious like where to look.
I guess. I mean, you have to get out far enough. Um, like it could do a lot of stuff in between. Like here's another graph with the same answers. These have the same. Oop, boy, that erased. That was bad. This has the same answer, but it does all this other stuff in between. But you don't care about that. It's just like noise. You just want to get to the part that you care about.
Or it just goes on forever. So like
Yeah,
all the movement's kind of nonsense.
yeah. It's like just give me the big picture.
Uh-huh.
This is
Is
the
there a
big.
way to say like which way is going up and which way is going down, or does that just not matter because you can just see it?
It's right. It's right and left, up and down. It's actually
Uh-huh.
very simplistic.
So what signifies the right in the left?
Right is x goes to infinity.
Uh-huh.
Negative infinity is left. f of x to positive infinity is up, and this is down.
Up and down. Okay. All right. I think that all makes sense to me now. I was not
Great.
understanding that in class.
Okay. Let's do part E. We'll need the graph one more time.
What is the end behavior of the function?
I'm looking at E, even or odd
Oh,
symmetry.
what,
We just
EV.
did D. Okay,
All
so
right.
the even is, imagine cutting the graph right in the middle on the y-axis. You cut it right down the middle. I think of it as a mirror. Does it look the same on the left as the right?
Um,
Like if you were to flip it over, would it be exactly the same? Imagine you could fold your paper in half. Well, you actually could. You could fold your paper.
it
Um,
would, yeah, it would be, it's like, it would be on top of each other exactly.
yes. So that is even.
Even, I'll just say even symmetry because if you fold it over like a sandwich, it's the exact same.
Yes.
View.
So that's where you have to say it's the same, or like you said, flipped over, same left and right kind of thing.
All right. So, okay, so that's so evens right to left, then
Yep.
odds up and down. So
No,
that's
no,
what,
that's the mistake. Odd is something
okay.
totally different.
So
Um,
how does the odd work? Like if you just give me random things, because
yeah,
I
I'll draw.
understand neither
I'll,
answer, but I don't understand that.
okay, so I'll draw an odd one here. This is odd. And so the idea is it's actually called a rotational symmetry. If you were to rotate what's in the top right or the bottom left 180 degrees, you
And
get,
that would be like to the opposite little square.
yeah, now it could also be in another, it doesn't have to be that. Like here's another one that's odd. If you rotate this top left into bottom right,
Oh,
then you get it.
so it wouldn't just move to the square next to it, it would move like two squares over.
Well, these are called quadrants, and we want to, yeah, it's a rotation. It's a 180-degree rotation, but you're rotating
So,
it about the origin is what you're really doing.
uh, so like if it's 10-10, it'll move like completely, well, not completely around, but like just to the other corner, which would be -10, -10.
So you actually flip the x and the y value, or and I'm
Oh,
sorry,
right, right,
or
right.
I'm sorry, you
This is
negate the
just
x and the
like,
y value.
so is this just like geometry almost, like just
Yes,
reflecting
yes,
it 180 degrees?
yes.
Okay, what I think my problem was that I was reflecting it over the x-axis rather than just 180
Well,
degrees total.
well, it is. You take this top part and you reflect it over the x-axis and then the y-axis. But you have to do it both.
So I have to do it on
Or
both sides. So I was, yeah, I
or
was,
you reflect it over the y and then the x. So on the one I've
yeah,
given you, if I do that in green, see if I reflect it over the y and then I reflect it over the x. Or, I'm sorry, the yeah, it does work. And
okay.
if you
So
go
it's like
and if you
it's like a double reflection almost because it's
exactly,
both x and
that's
y.
so and it's more that's more complicated than saying a rotation. So it's why they don't say it that way, but that is what it is. And you can prove that. You can prove it, that's another class. Um, so you're supposed to sketch anything that's got that shape that I just gave. That will do it.
All right. The and okay, so I guess just along with sketching that, it never has to touch the X or Y. It never has to have an interception, right? Like being shown.
I mean, I would just go back to the red one. That's probably the best one. That most common one you might see. I would just graph something like that.
Just get like a little like just bang bang through the 0, 0.
Yeah, yeah, something like that.
Okay. All right. That's okay. That makes all right. It's yeah. I don't know what it is necessarily like, or the way you explain it, just compared to my teacher, it just makes so much more sense.
Well, I think it's you're getting your questions answered, and you've had some time to reflect on it. And
I guess that's true. Yeah, because it's I don't know. It's just kind of frustrating because like I'll go into these tests and it's like I know how to do everything on the test. Like I've done it with you. Like I've done my little like practices or whatever. And then like on the test, it's like I'll forget how to do it.
yeah, well,
Not
don't
in
lose
like a
hope.
way that
Don't lose hope. One bad quiz doesn't make or break anything. One good one
yeah,
doesn't either.
I guess that's true. But yeah, I don't know. It's just kind of like frustrating the like memorization because it's like I remember how to do it, but it's like if I forget like a step, then it like kind of gets me like on this like downward spiral almost with it, which is just kind of like a total pain.
All right, what else do you like to work on tonight, Zach? We got a little time left.
Um, let me see. There's just paper wise if I have. Okay, so I mean, we did this. I don't really know how I'd send this over to you without it just being like 50 different pictures, but we're looking into like, oh, I mean, even in odd symmetry, we just did that pretty much, correct?
We did that. We just did even and odd
Yeah.
symmetry.
So, I mean, I think everything that I'm doing right now, just like overall vocabulary, would be evaluate a function and behavior, absolute maximum, average rate of change, point slope form, and the secant line.
Secant, yeah, secant line.
So we sort of covered all of that just in that one paper, correct?
Yes. I'd like you to
Okay.
do more average rate of change if you're willing.
Yeah, definitely. Like I think just the most practice I can get, the better. And then, do you know if there's any like just things I can look up online where it's like practice papers, kind of just similar to this one?
Yeah,
That's
the average rate of change. The end behavior is slightly different than average rate of change. So yeah, we can do a couple of each.
sounds
Is
good.
that all right? Is that all right?
Yeah.
Okay, so let's say f of x equals 4 minus x squared. We want to find the average rate of change from 1 to 3. All right, so this is A, this is B. The average rate of change is f of B minus f of A over B minus A. This means you have to find f of 3 minus f of 1 over 3 minus 1. So you're responsible for finding f of 3 and f of 1.
So I just take those x coordinates and put it into that formula x squared.
That's right. That's right. That's it.
So I don't actually have to worry about like the
No
like
graph.
okay.
No graph.
So
And we
then
should do this without the graph anyway. That's the whole point. We should,
yeah. Okay, so then f of x equals 4 minus 1 squared, which would be 3, positive 3. And then for the actual positive 3 is the x insert. It would be f f of x equals 4 minus 3 squared, which would be 4 minus 9, which would be negative 5. So there would be
okay.
3 and negative 5. So I'd just write minus 5 over minus 3, and then 3 minus 1 equals minus 8 over 2, which would be negative 4.
Okay. Very good.
But then, okay, so for the formula, like no matter what, it is always FB minus FA over B minus A.
Yes.
And then, So the B is just always before the A.
Yeah.
Okay. And then it's always, and it's like never positive, it's always negative.
It's always subtracting. We don't know if the
Always
answer is positive or
subtracting.
negative. Yeah.
Oh, yeah, that's what, or sorry, that's what I meant. Just like in the equation, like it's always subtracting.
Yeah.
Okay. So,
Okay. Let's try another one here. We want to find the average rate of change from 1 to 9.
okay. So then that would be f of x equals square root of 1 minus 3. And then is the square root of 1 1 or is it
Yes.
2?
Yep. These are the ones to remember. And I would strongly recommend you write out the formula and put the numbers in. That way you get the right order. It's easy to get the wrong order.
Uh huh. So then, okay. So I'm going to write this out. Get my notebook. Okay. So that F B minus F A over B minus A. So then that's 1 minus 3 minus 2 minus. Then 9, 3 minus 3, 0. So minus 2 minus 0 over. And then, okay, so minus 2 minus 0 over, and then B and A would be 9 minus 1. So then that would be minus 2 over 8, which is minus 1, negative 1/4.
Okay. So that sounds okay. So it would be f of 9 minus f of 1 over 9 minus 1. So this is 0 minus a minus 2, though.
0 minus minus 2. So then
How would that change your
that
answer?
would make it positive rather than
Yes.
negative.
Yes. Yes.
So minus minus. Okay. Um, I guess what does this lead into? I guess because like I know like this gets to the answer for like this problem, but does the math from this like advance using the same kind of formula, or is this just kind of it, and then you learn other concepts?
It's the basis of calculus, but they tend to just not ever bring it up again in your course.
Uh huh. So like I don't need to like
You just need to know how to calculate average rate of change.
okay. So the just the formula is the main thing that's like
Yep.
oh average rate of change AROC. Okay, that makes
Yeah,
more
AROC.
sense.
Sometimes they just shorten it to
AROC.
AROC, but it's average rate of change.
Okay. Um.
All right, could you graph this? I was gonna have you graph something so we could do some end behavior.
Uh huh.
All right, could you graph this and tell me, sorry, make it cubed. Sorry, I didn't realize that's what it was. Could you graph that and tell me which of these four graphs it most looks like?
Okay. Minus.
And you could
I'll
use
just write it
Desmos.
down. So x3 plus 16x plus 6. Two x3 plus 16x. And then, okay, so once I have that, then I'll click.
Which of these four graphs does it look like? Roughly.
I'm just trying to figure out the button that gets me to the turning it into a graph.
Oh, you got to go to the Desmos calculator, which is
Yeah, that's what I was.
different than the thing I just sent you.
Oh, okay,
I,
my bad.
I
Oh,
think
right, right, right. Yeah, it
it's
shows
it
you the like big
we
graph.
think of a calculator as what we have in front of us, but it's actually they call it the calculator the graphing tool.
Yeah, like all right, I'll plug that in real quick. I copy and pasted it, and then definitely need to zoom out. It looks most minus 2x3 plus 16x minus 26. Like the last one, I believe. Not really, though. Mine's really kind of weird looking.
It should look like this one here, meaning like it goes up and to the left and down and to the right. And
Um, Actually, yeah, it does do that. It's just very like,
right, it might do a bunch of other stuff in between, but we don't really care. We don't really care what it does in between here. We just care about what happens at the ends.
yeah, okay. So it is going out to the left and down to the right,
Yeah.
or
So now we
it's
can say
going.
as x goes to infinity, as you go to the right forever, what happens to the y value as you go to the right forever?
The
Go to
y.
the
So as you go to the right forever, the y value will negative. No, will in, negatively infinitively go. Will go negatively for infinity.
negative
I don't know how.
infinity.
Negative
Okay.
infinity.
And as x goes to negative infinity, as you go the other direction, as you go left,
So is left minus infinity and right's positive
yes,
infinity? Okay.
yes, yes,
And then as you go to the left, you will go for just infinity, positive
positive
infinity.
infinity. There it is.
Hmm. Okay. So, and then I don't put any numbers in that or anything. That's just
No
tells you everything.
numbers. Yeah.
No.
You have
So,
to know this format. You have to know how to write this. It's like that. Remember that domain stuff where it was like X such that you have to like know, you have to know this form.
okay. All right. It's not too bad. I guess it's just more of a memory thing as well.
Okay. That is gonna probably do it for us for tonight, Zach.
Yeah, definitely.
So
Thank you for the help.
I hope that's helped. For the next, or at least for next week, because I know you got fall break coming up, but we're gonna be at 6 o'clock next week. Does that work for you?
Yeah.